Welcome to the seminar, A Brief Insight into BESEN, the maybe world's first feature-complete ECMAScript Edition 5 implementation by BeRo of Farbrausch and me, Red of Mercury and Titan. So next slide. So this is what I'm going to do. First, I'm going to give you a brief introduction of what BESEN actually is, and then I will talk about the core features of BESEN, followed by its components, parser components and runtime components, and I will talk a bit about how BESEN is perceived by others. So actually we have replaced any text in the beam slides with pictures of cute animals. So I'm going to, because it's a lot of text which I'm having here, and we don't want to kill you with all the texts. So BESEN is a ECMAScript 5 edition implementation written completely in Object Pascal. It's usable with Delphi 7 and Free Pascal. It has a native code just-in-time compiler for 32-bit and 64-bit AMD and x86 targets. And for other targets, it has a fallback bytecode virtual machine for ARM and whatever. And why was BESEN written? This is a funny story actually. A few years ago, I myself started writing a script engine which was object-oriented and had typeless variables. And so I was very happy for my achievement, and I told BeRo about this. And he was like, hey, I can do this better than this. And a few months later, he came back with BESEN, and he completely pwned me in any way imaginable, because he is like feature complete ECMAScript 5. So ECMAScript, you know it from your browser probably. Most of you people know it as JavaScript. And ECMAScript Edition 5 was the next edition after ECMAScript Edition 3, because version 4 was skipped and ECMAScript 3.1 was renamed to ECMAScript 5. So what's so hard about implementing ECMAScript Edition 5? As BESEN was one of the first engine which actually implemented all the features. It was feature complete before any other browser was. It's a very, very dynamic scripting language. Almost everything is an object, and objects can have properties which can be dynamically added or removed, and you need a fast lookup for this, and objects can also be freeze as a prototype chain. And habe ich irgendwas vergessen? Okay, shall we go on? So the core features, we made a little graphic here. So there's this is great, yeah. Thank you. What are you doing? Technology, it works. So yeah, you can see here how it works. First there's Alexa, which gives its stuff to the parser, which transforms it to an abstract syntax tree, which is then optimized. Then bytecode is generated, which is either compiled by JIT or put is executed in a virtual machine, depending on what is there's different use cases. Because when you directly want to execute your code, you don't need to transform it you don't need to compile it just in time and then execute it again. You can instantly parse it and don't have to translate it into JIT, because this will only take longer. But if you have functions, those will be usually translated into JIT. And there's also the garbage collector and an own regular expression engine. And I'm not sure if I'm going to talk about this too, but so let's go to the Alexa. Cute puppy. It's a simple handwritten lexer from left to right, top to bottom. It takes any charset source as charset source text as input. Everything is UTF-8 internally. Lookup of keywords is done per binary search in a linear sorted string array. Identifiers will be stored in a hash map for later lookups with, for their identifier IDs. And there is integer and 64-bit double floating point numbers parsing with own routines and arbitrary precision arithmetic. Regular expression parsing with testwise pre-compiling of the patterns to find syntax errors in these regular expression patterns. And outputs on the fly token stream for the parser. So we go to the parser. It's a cute owl. And it reads the token stream from the lexer, and it's also a handwritten recursive bottom-up parser. It has a strict and non-strict mode. I personally never used strict mode, so I cannot talk much about this, but and the parser finally builds this abstract syntax tree. Next. Which basically is an object model of the code like this, and this is then first optimized. So if you have some additions of constants, this addition is actually merged into one single constant. So code is optimized. Also, this is used for dead code elimination. If, for example, if you have a break somewhere and there's code beneath it, it will be removed. But only is it safe in valid ECMAScript context. And code transformations as well are optimized if possible. So the bytecode generator, it takes a syntax tree as input, and it generates register-based bytecode of it. It applies also very simple basic p-pole optimizations, and tries to apply register-based copy propagation when possible. And it also tries to avoid dead stores. It's so no. Please wait. So the JIT compiler is triggered by function code entry or global code entry. It takes the bytecode as input, which was produced before, and it outputs native code for 32-bit and 64-bit targets. And it's a simple conventional JIT compiler, which by appending native code templates for each bytecode VM opcode, it's rather simple but effective.
Is there a small step between to convert first to assembler and then using an assembler to create?
No, not assembler code is not generated directly. The corresponding not bytecode, but like it's the real assembly byte code. Machine code, thank you.
Machine code, yeah.
Yeah. So object structure IDs. ECMAScript is incredibly dynamic language by design, but in most cases, many objects are actually used in a way that resembles more structured object-oriented classes. So many objects can have often the same underlying structure underneath with the same properties in the same order. And in these cases, we can cache and assign these object structure layers to object structure IDs, which is basically a 32-bit integer. And these IDs records can be linked together to save memory space for multiple objects. So if you have a first base object, which has a child, and this again has another child, and you can directly access it this way. And these object structure IDs, ID records are also garbage collected. They have a simple reference counter because there's no recursion possible. You cannot build a recursion chain. So this makes things easy. If the ID counter overflows, or if there's too many of them, a cleanup is tried to remove unused records and reassign everything. So we can see maybe the ID counter overflow is maybe avoided. If this fails, inlining cache will be disabled and a string hash map lookup will be used instead, which is a bit slower but still works quite well. Garbage collector. So if you ever have written, if you know about garbage collector, this is a three-color garbage collector. So there's white objects, black objects, and gray objects. White objects are objects which are candidates to free, so they can be removed. Black objects are objects which are in use and have no references to white objects. And gray objects are objects which are reachable from other, from root reference objects, black objects, so to say, and but objects again references by gray objects that aren't been scanned yet. I don't know. The gray objects are objects which are reachable from the root references, but the objects referenced by gray objects aren't been scanned yet. Oh, okay. So the gray object list is initialized to objects which are referenced directly at root level, and all other objects are initially placed in the whitelist object list. So objects can move from the white object list to the gray object list and from there to the black object list, but it's never in the other direction, otherwise you would have corruption. And no black object can directly point to a white object because that would be invalid. And the basic idea of the algorithm is that you pop an object incrementally from the gray object list stack and move it to the black object list stack, and move all the white objects references to the gray object list stack. And this is done repeatedly until the gray object list is empty. So you either have black or you have only white items, and depending on the color you can remove them. So you sweep all objects from white object list, and then you have removed all unused references. So inline caching. So BESEN has 3 inline caching states. First is monomorphic, which is a simple lookup if depending to determine the type of the variable. Oh, thank you. It only caches our object property index item of an object structure record. Polymorphic inline caching caches up to 8 object index items of multiple structure records. So if you have different types, this is used to have a faster lookup. And megamorphic is basically brute force hash map lookup. And monomorphic inline caching is done on JIT level, so it's compiled into the JIT code. And if this fails, the bytecode VM opcode dispatcher will be triggered from the JIT code, and the megamorphic lookup code is also only done in the VM. So only the monomorphic inline caching is done by JIT directly. So, BESEN seen by others, but first we will show you some screenshots of a performance test. It's a simple prime number generator, I think, was it? Yeah, it's finding primes. And this first screenshot you see is the BESEN IDE itself. And you can see it took 138 milliseconds to find these amount of prime numbers. I cannot actually see the slides, but so, and then we have Google. What? Oh. I think your notebook is broken. So then we have Google Chrome, which is slightly slower than BESEN. It takes about 20 milliseconds more for the same code, and Chrome is usually very fast. Next one. Firefox is actually, I think it's a bit faster than BESEN is, but it's really a close call. Opera actually beats BESEN, which is the only browser which actually does it in this performance test. Excuse me? That depends. There's so, jetzt mal diese tolle Liste da anzeigen. Das kannst du eigentlich nur tun. Ne? Browsers actually partially implement ECMAScript 5. There's only not all features are available. There's a feature list overview of all the ECMAScript 5 engines, which we will open right now, as soon we have some access to the internet. So I should probably stand up for this. I hope I don't will create a feedback blah when I step into the field of the boxes. So this is Internet Explorer 8, 9, Firefox 3, Firefox 4. Safari is the next, and this is actually BESEN, and you can see it's the only entry which has everything green. Everything is supported, even strict mode, which is the only difference between the compatibility between Firefox. Oh wait, why is there strict mode? Ah, okay. It was Firefox 3 before. I see. You confused me. Sorry. So Firefox 4 is the second. Was second when it came to a full feature-complete ECMAScript 5 implementation. So current browsers actually are slowly catching up. Oh yeah, Safari is actually very slow, but if you think that it couldn't get any slower, there's always Internet Explorer 9. So even if so you can see that BESEN actually does seem to perform quite well regarding to other browsers. So yeah, just to give you an idea how good it performs or not. And you might have read about it that there has been nearly a war being going on between the different browser vendors who produces the fastest JavaScript, and I think Internet Explorer has not won it. So we also have a video of someone from Google, I forgot his name actually, Mark Miller. He's been talking about JavaScript, and let's just listen to what he has to say about BESEN.
Which is the JavaScript interpreter. Well, it can run either interpretively or it can compile to bytecodes. But the JavaScript, I'm going to just call it an interpreter, that runs on top of the JVM. that has a full implementation of the new ECMAScript 5 APIs, so all of this attribute manipulation, including object.freeze. It has, as far as I know, a full implementation of all that. It's at least feature complete in the sense that all of the APIs are there. I don't know how fully tested it is because the ECMAScript 5 tests themselves are only now accumulating, and they're very far from complete at the moment. But Rhino does not yet have ECMAScript 5 strict mode.
He's actually talking
And
about
therefore
Rhino
does not yet have the repair of scoping or the repair of encapsulation. Other than Rhino, as far as I know, all of the other use of JavaScript outside the browser are, all those uses, as far as I know, are making use of JavaScript engines that were written for the browser. So Node.js using V8. I think that there's some using I think that for each of the browser engines, I think there's somebody using it on the server side. Now I should mention here, the first complete implementation of ECMAScript 5 was outside the browser. It was done independently. It's called BESEN, B-E-S-E-N. It was done in Object Pascal. And it looks great. And it was, it was tremendously early. It was way ahead of everybody else. And it just sort of popped up on the list one day with this announcement that, hey, there's this, I just, quietly did this complete implementation of the ECMAScript 5 spec in Object Pascal, and it seems to work. Okay, now, on browser adoption, let's just let's do the roll call. I'll just speak for the.
So this was Mark Miller from Google talking about BESEN and other ECMAScript engines outside of the browser. So actually we are already through. So do you have any questions? I will try to answer them my best. As BeRo actually knows all of it, and I'm only a user of his engine. Any questions so far?
Will it be possible to use it? Is it possible to use it as a replacement for Lua, for example,
yes,
for coding somehow?
Yes, I use it myself extensively, and it has a really easy integration. So if you write an object, you only have to inherit it from a BESEN object. And all published properties and functions are actually directly accessible in your script. So you only have to write your class, like usually, and you can instantly use it in your script, which is very nice. It has very little overhead to implement new stuff for your project.
And it also is possible to manipulate directly in the memory somehow, that I have a list of 3D objects and I want to steer it via ECMAScript.
Well, for this particular case, you would have to write your own wrapper. So you have, for instance, an object which gives you back whatever information you want, and then you can maybe even write more wrappers in ECMAScript. This is actually what I'm doing myself. I write a simple basic class which is a wrapper, and then I write a more extended class which only uses the basic wrapper functions in JavaScript, ECMAScript myself. This has advanced. This is very easy because if you have bugs, you can always fix them in the script code and not have to recompile your code again and again. And this is really easy for prototyping or whatever. Whenever you need to get stuff done fast.
Thank you.
the first question might be redundant because it was a little late. So, what's the license it's released under? Is the source code is available? I guess from
source code is available. Maybe we can. Actually, I don't know which license it is exactly, but I'm pretty sure BeRo will now show you the license file.
Another might be redundant question is implemented in C?
No, it's not implemented in C. It's done in Object Pascal.
What? No.
Yes. So this was mentioned at the beginning of the talk. So yes,
this
is one of the things that makes BESEN kind of special.
What's the memory footprint?
What?
What's the memory footprint? I would have omitted this question if it was on the JVM or whatever.
Memory footprint is rather small. It actually depends on your project, but if you just implement if you just use the parser and with no additional stuff around it, you will be there's not actually much memory memory used. If that was your question, though.
Interesting.
What are you doing actually?
So
BeRo just started his BESEN shell, which is actually a ECMAScript shell, so you can enter any kind of JavaScript and it will be executed directly. And now he will be showing his mad coding skills to show what's possible with this. This is a strict node, as you can see, and it's actually being very strict.
I think it's very interesting, perhaps for others, to know that you are still working on WebGL implementation for the engine.
Well, yeah, this is another use case. He mentioned WebGL implementation. So BeRo is working on this. Do you have a demo for this too? That would be really neat. It doesn't work.
Good. Another question, now that you know really what's going on inside, are there any best practice hints or something to avoid to improve performance or memory footprint, whatever?
What I've been trying to do is to write some, I wouldn't call it a program, but stuff which works in my own implementation of in my own program using BESEN and in a browser. So if you use a browser, you have to write your own wrapper classes which just use HTML and whatever you need to simulate what your native objects you implemented with BESEN provides the same functionality. And my personal best experience is there that whenever you manipulate the document object model in the browser, things will get really slow. Canvas, if you use Canvas, it will be significantly faster because it's actually meant to be fast. But this is, if you want to do stuff like this, this is my advice I can give you.
Okay, and another question is debugging JavaScript is usually quite tricky. So are there any tools or stuff which helps in debugging or just monitoring the script?
Also here my personal debugging skills are that I have a debug out function. So I basically just put an alert between my code which does not work. So there's of course the full try-catch exception handling within JavaScript, and if you don't catch it yourself in your script, BESEN will actually throw an exception within the native code. So you have your means to debug it. If you have native functions, you can always put a breakpoint in there, and if it's triggered by the script, you can trace through your own code, so debugging is possible. But I don't think BeRo has written a full JavaScript debugger yet. I'm not sure what BeRo is doing here, but actually this is some bug in Firefox 4, which is obviously showing off in a test case of ECMAScript 5. Yeah. I'm still not seeing. Can you like mark it? Oh, up there. So yeah, and have you already started in your own? Of course you have. Okay. Any more questions?
What's the use case for compiling your ECMAScript code? Is there any performance win, or is it just that you have your executable that you can deliver to your user?
Well, of course, there's not a performance gain when you have a language like this, when you can write native code which is directly converted into assembly. Of course, there's a lot of tricks going on which makes the code go fast, but it's still no reason to implement your 3D rendering engine in JavaScript and use it there, and instead of writing it in native assembler code. So it's not really, you shouldn't use a BESEN in your projects if only for speed, but for flexibility, because it really gives you the ultimate flexibility to do whatever you want. You can, if you can change, if your program's based on BESEN, you have just the flexibility with any other scripting language, but this time it's JavaScript.
Is it possible inside BESEN to access objects from Object Pascal?
Yes, I think you went here when I mentioned it. If you write an object and you want it to be accessible within your script, all published properties are received via RTTI, out properties and functions. And as soon as they are published, they will be accessible in the script as well. So it's really, really straightforward to implement your own objects and functions.
Okay, another question. I think it was already asked, but I didn't hear the answer. Can you show the license file or tell what license this is under?
License file. Actually, there's more than one license. It's either open source or Ask BeRo. Please wait a moment. So it's AGPL3 and his own license. So you either have to publish your whole project as open source, just like BESEN, or you have to get in touch with BeRo and talk about licensing options if you want closed source applications. So any more questions about licensing? Okay then.
Is there some API documentation yet? And is it possible probably to show a glance of it, like how the API looks in a bit like
I don't think that there's a documentation.
Embedding, injecting objects and all that.
There's no documentation yet. So do we have any example source code here which uses BESEN? That would be really neat. Okay. So here we see the file object, which implements some basic functions for reading and writing in files. And you can see it's derived from a TBESEN native object. And you can see the published properties and functions and procedures, which are just defined in the published section, and if in the constructor they are automatically retrieved via RDDI, and there's no more overhead than this. There's also some functions for constructor initialize object and finalize object. Those are called when new instances of the class are getting created within BESEN. So. But for most, this is only initialization code for the class code itself. It's opening a file here. And scroll mal runter, wo du den Kram registrierst. The only overhead you have to access your object in the script parser is that you have to register your object type, which you can see. So there's native functions are registered here, and native objects like the arch in this line. So this is how you set up BESEN yourself. So it's not really hard to do it, but there's still no documentation left except for this example source code. It's supplied on the side.
On the ABI of Object Pascal, right? Like
Excuse me?
It pretty much relies on the ABI of Object Pascal.
Exactly.
The binary interface. So you would have to write wrappers for it if you wanted to use it with another language, like C or whatever.
Yeah, writing a wrapper would be not so like trivial, I think.
Or writing some adapter that adapts the Object Pascal ABI.
Of course you could. What?
Or writing some adapter that generically adapts the ABI of Object Pascal. Okay.
Okay. Any more questions?
Okay.
So. Okay, then some last words for me. So you can download. I'm pretty sure you will be able to download the slides that I used, which I used to read all the text that I didn't understand. So if you have more questions about BESEN, you can always get it on this side soon. And thank you for listening.